Welcome. Next, let me describe the second derivative test for functions of two variables. Here we have to assume that f has continuous second-order partial derivatives and that x0, y0 be a critical point. We have to define a new quantity, the discriminant. It's fxx fyy minus square of the partial derivative xy. It's the product of the two pure second-order partials minus square of the mixed partial. Now, if the discriminant is positive and so is fxx, then x0, y0 is a relative minimum. If the discriminant is positive and fxx is negative, then x0, y0 is a relative maximum. If the discriminant is negative, then x0, y0 is what is called a saddle point. I will describe this pictorially in the next session. For now, let me just say that a saddle point is neither a relative maximum nor a relative minimum. A saddle point is one where in some directions you have a relative maximum, in some other directions you have a relative minimum. It's a bit like saddle you put on a horse. If you take the direction where your legs go, then you have relative maximum, but along the horse's back where you sit is a relative minimum. If the discriminant is zero, then the test fails. Any of the three possibilities can happen. There are other possibilities as well. Deciding between these is very hard, so we will just ignore that. An important word of caution, this test is more complicated than the one variable case because you have to test two numbers and the discriminant must be positive for either type of relative extremum. It's not enough to look at only one of the pure second order partials. So it's possible to give examples where fxx at x0, y0 is negative and you don't have a relative maximum. You have a saddle point. You can also give examples where it is negative and you have a relative maximum. Note that in the second derivative test, it's not enough to look at fxx. For both relative max and relative min, the discriminant must be positive. Discriminant negative means you have a saddle point, which is not a relative extremum. Now it's possible that fxx is non-zero and you don't have a relative extremum, but you have a saddle point. You really need to look at both the discriminant and fxx.